Hello again, this is the Math Dog. This video is on vertical translations of linear functions. I would say this is the 8th grade Algebra 1 level. Of course, anyone can watch it at any level, even for review. So you should have a pencil, graph paper, and a ruler ready to work the practice problems in this section. That would, I think, optimize your use of this video. This video is not to be shared or reproduced without the written consent of the creator, myself, the Math Dog. So it is highly recommended by me that you watch my video on horizontal translations of linear functions before doing this. At the end of this video, I'm going to try to tie together the relationship between vertical and horizontal translations of these functions. Alright, so let's get started. Alright, the most basic linear function is the identity function, f of x equals x. It's also called the parent linear function because all linear functions can be built up off of this. So it's called the identity function because, for example, this point right here, 5, 5, the input value of 5 gives an output of 5. This point here is -4, -4. An input of -4 gives an output of -4. So I'll just fill out a couple things on the table here demonstrating that again. So if x is -3, f of -3 equals -3. Remember, I've said that this does not mean f times -3, this means f of -3. This is function notation, meaning the function f is evaluated when x is -3. So this again would be the point -3, -3. And just do one more here. When x is 5, f of 5 is 5, and we would get the point 5, 5. So we plotted -4, -4, 5, 5, but let's plot, just for good measure, plot -3, -3. Alright, we'll be using this function in this video quite a bit. Alright, so now we're doing vertical translations, which are down or up. So the first problem here, take the function f of x equals x and going to take it 5 units up. So I'm using the same method I did in my horizontal translation video, except now we're going up and down instead of across. So my original axes, here's my line, f of x equals x. My original axes, the origin here is 0, 0. I call this the old. So I'm going to translate to a new set of axes, a new origin here, and I'm going to call this the capital X, capital Y axes. In the old coordinate system, this point right here is 0, 5. In the new one, I'm going to call it 0, 0. Okay, so to get to move from the old axes to the new axes, you can see here that I have to go to get from old to new. For x, I don't have to do anything, so big X is little x, but for y, to go from old to new, I have to take away 5, so big Y is little y minus 5, because 5 minus 5 is 0. So now substituting here, I get little y minus 5, substituting for big Y equals little x, and if you rearrange that, you get y equals x plus 5 if you add 5 to both sides. Okay, you can also call this function, let's graph that in first. So we're going to plot the new function that we translated. So slope of 1, 1 over 1 up, 1 over 1 up. Let's draw a line through those sample points I put in there. So this is y equals x minus 5. In the new axis system, it is y equals x. This is actually the line y, capital Y equals x. And I'm going to call it also g of x. I'm going to also call this function g of x now. So g of x is x plus 5. Notice it could also be written as I can replace, since f of x is x, I can replace this with f of x plus 5, since f of x and x are equivalent here. So these are all different ways of writing the new line that we've shifted 5 up. Okay, similar problem, shift this time f of x equals x 6 units down. So here's the old original axes, little x, little y. Okay, little x, little y. Let's put that over here. Little x and little y. So now I'm going to slide 6 units down. Here's my new axes, which I'm going to call, let's put the y where it should be. Better location. This will be big X, big Y. So this point here in the old system is 0, -6. In the new one, it's the origin 0, 0. So the rule here is to get from old to new for X, I don't have to do anything. I'm just going 0 to 0. So big X will equal little x. But to get from -6 to 0, I have to add 6. So this is going to be, so y is going to be little y plus 6. Okay, so now substituting in for big Y, I have little y plus 6, and replace big X with little x. Subtract 6 from both sides, I get y equals x minus 6. So this is the new line, which I haven't drawn in yet. It should be right here. So this is the line y equals little x minus 6. In terms of g of x, I could call this line also g of x here. So g of x is going to be x minus 6. And also, since f of x equals x, I could also call this g of x equals f of x minus 6. So there's 3 different ways to write, I've shown to write the translated function. Alright, so stop the video. Here's the practice. I want you to translate f of x equals x 3 units up. I want you to do the translation here, fill in the coordinates on the old system, new system, and come up with the function for g of x and for y. So when you're done, turn the video on and see if you agree with what I got. Alright, so let's fill this out here. So this is the original origin 0, 0. This is now moved 3 units up. So this point in terms of the old coordinate system is 0, 3. In the new coordinate system, this is my origin, so this is going to be 0, 0. Okay, so to go for x here from the old to the new, nothing changes. So this is just big X is little x. But I have to subtract 3 from y to go from 3 to 0. So I have little y minus 3 here. Now substitute in for big Y, little y minus 3, and then substitute in little x for x. Then rearrange, add 3 to both sides, you get y equals x plus 3. Okay, let's draw that line in. There's a slope of 1. Okay, so there is the new translated line, y equals x plus 3. We'll also call this g of x. So g of x, again, could be x plus 3, but since f of x equals x, I could also write this as f of x plus 3. Alright, here's another practice. F of x equals x. Shift 7 units down. Fill in the missing information. Stop the video, and then when you're done, turn it back on and see if you agree with what I got. Okay, so here to fill in the missing information, this is the original origin, 0, 0, so in terms of the old coordinate system, this would be 0, negative 7. And this would be 0, 0, because this is the x, this is the origin in the new system, the way I've done this. So I'm, again, shifting 7 units down, so now to go, I don't have to do anything for x, so x stays the same here. Big X is little x, but y I have to add 7 to negative 7 to get 0. You get 0 here. So I have big Y equals little y plus 7. Okay, so now substituting in for big Y, I get y plus 7 equals x. Subtract 7 from both sides, I get y equals x minus 7. So that's one way to write the new function. Okay, I could also call this, so this is my graph y equals x minus 7. I'm also calling this g of x. So g of x is x minus 7, or I could write, since x in this case is equal to f of x, I could write f of x minus 7. Okay, let's do an example. Translate f of x equals negative 2x down 5 units. Okay, so the original coordinate system, this is 0, 0. We're now calling this 0, 0 for the new coordinate system, and it'd be 0, negative 5 in the old. So again, no change in x. So that's just going to be big X is little x. But to go from negative 5 to 0, I have to add 5. Okay, so now notice I have a slope of, so I'm not starting with y equals x this time, I start with y equals negative 2x. So I've taken the parent function and I've made it so that the slope is negative 2 instead of 1. Okay, so basically really what we did was we stretched from a slope of 1 to 2, then we reflect, you could think of it as then reflecting it over this line to get the slope of negative 2. Now I'm going to make my substitutions, y plus 5 for big Y, little y plus 5 for big Y, and then little x for big X. So then I'm going to subtract 5 from both sides, so I get y equals negative 2x minus 5. So I could also call this function that I'm going to graph in here g of x. That would be negative 2x minus 5. And finally, since f of x is negative 2x, I could write g of x as f of x minus 5, meaning that I'm shifting the function f of x down 5 units, which will put me here. So let's draw that in now to finish this out. Slope those negative 2 this time, 1 over 2 down, 1 over 2 down. Could go 1 left, 2 up, 1 left, 2 up, 1 left, 2 up. Get some points in there to help graph it. Okay, so again, this line is y equals negative 2x minus 5. It's also, I'm calling it g of x. Okay, so now here's a practice for you. Translate f of x equals negative 1/2 x 4 units up. Stop the video, complete the information, graph the function, and give all the information over here. Okay, so let's compare what we got here. So for starters, so I have a slope of a negative 1/2. So again, the parent function was f of x equals x. So basically I flattened it from a slope of 1 to 1/2. So instead of going over 1 up 1, I go over 2 up 1. Then I reflect it over the y-axis and I get this y equals negative 1/2 x, or f of x equals negative 1/2 x. So this is the function f of x equals negative 1/2 x. You could also call it y equals negative 1/2 x. So here's my original origin. I am moving the function 4 units up to here, or you're going to move it 4 units up to here, and well, hopefully you did. So in terms of the old coordinate system, this would be 0, 4. In terms of the new coordinate system, right here, this would be 0, 0. So x doesn't change from big X and little x, so they're the same here, they're equal. Y though, to go from old to new, I have to subtract 4 from little y to get big Y. So now replace big Y in this is, so let's draw the graph in here. So this is negative 1/2 x. So from here to the new origin, I go over 2 up 1. Try it again. Over 2 up 1. Over 2 up 1. Over 2 up 1. It's a downward falling line because it's a negative slope. Could go over 2 down 1. Then draw the line through the points. Alright, let's make our substitutions here. So I'm going to replace capital Y with little y minus 4. And I'm going to replace big X with little x. So adding 4 to both sides, I get y equals negative 1/2 x plus 4. So g of x also could be negative 1/2 x plus 4. But since f of x is negative 1/2 x, I could also write g of x as f of x plus 4, which means I'm shifting the function f of x up 4 units. Okay, summary of this video. Functions of the form f of x equals x minus b are shifted b units down. For example, f of x equals x minus 4 is shifted 4 units down. F of x equals x plus b, those types of functions are shifted b units up. Example, f of x equals x plus 11 be shifted 11 units up. So if I write in g of x equals f of x minus b, these functions mean the function f of x is shifted b units down. For example, g of x equals f of x minus 4 would be the function f of x shifted 4 units down. And g of x equals f of x plus b, these functions are shifted b units up. For example, g of x equals f of x plus 3 would be shifted 3 units up. Okay, so in conclusion now, if you've watched my video on horizontal translations, which I hope you have or are familiar with them, let's compare horizontal versus vertical linear translations. So these two actually, so I have a graph here. Here's my original function f of x. In this case it's f of x equals x. Notice that the horizontal translation, g of x equals f of x minus 5, so here is g of x, I'm shifting x 5 units to the right, is equivalent to the vertical translation. I'm calling this function h of x is f of x minus 5. So these generate the same result. Okay, this is a shift of 5 units down, this is a shift of 5 units to the right. And we explained in the horizontal translations video why it's kind of counterintuitive, because you would think this would be, at first you'd think this would be 5 units to the left, but actually it's not, and we demonstrated that. So then another example here, comparing horizontal versus linear vertical, comparing horizontal versus vertical linear translations. I have a graph here. Again, I have f of x. So I have g of x here, which is a translation of f of x 7 units to the left, f of x plus 7. And that turns out to generate the same result as the function h of x, which is the function f of x shifted 7 units up. So in this last part of this video here, I am comparing the horizontal translation versus the vertical translation. And then back here, same thing, the horizontal versus the vertical. And this concludes the video. I hope it was helpful. I will be putting out a video on composite translations of linear functions, which will include both horizontal and vertical all in one problem. Thank you. Have a good day.